Yes, sir.
Okay, Buddha. Right. So welcome back. Still, I see only 5 people. Only 5 people. Only 5 guys. Now we have 7 people. 7 students. Students, mic is on, Buddha. Mic is one student's mic is on. Why there are quite low number yet? No. Okay, now we have 16 students. Good. Right. Okay, so students, welcome to today's lecture. Happy to see you all. And we discussed last time what? What was the last theoretical content we discussed? What did we discuss?
So we talked about non-parametric and parametric statistical tests.
Very good. Excellent. Very, very nice. Thank you, Buddha. Thank you very much. So, yes, you are absolutely correct. We discussed about parametric and non-parametric analysis, right? And particularly, what are the non-parametric analysis that we can perform for independent sample t-test, right? Then paired sample t-test as well as one way and all. We discussed about that and we applied it. And after that, there was this class group presentations. Is it? Good. Confirm what we did. So now what we shall do is we shall proceed with our discussion. Today I'm going to discuss a very, very important analysis called panel data analysis. Right. So you can see that this is your course, isn't it? 16 CDWD, 16 CWE. So we shall go to today's discussion where I'm going to discuss under week 9 panel data analysis. So I have a Word file as well as you might see it's an Excel file, but actually it's not an Excel file, it's a CSV file. Right? A CSV file is a command delimited file, a basic file which has numbers. But you can open that using Excel. The default is Excel indeed, but it's not an Excel file. It's kind of a text data, numbers stored right in a structured way, right? That's what it is. But never mind about that. Let's call a file that will be open in Excel, and we'll see what kind of information is there. So I encourage you to open these two files, right? Please open these two files. Download the Excel file as well as the CSV file as well as the Word file. Is it okay? So let me stop share the screen. Can you do that? Is it visible to you? Then on it, is it? I think you can see that, right?
Yes, sir.
Okay, good. So please download it. Right. And then now let me reshare the screen to you. Right. Okay, I'm going to now open it. Here is the panel regression file. Panel regression analysis and panel, right? The CSV file as well as the analysis. So the same two files, I'm going to open that now. I'm going to open the panel regression analysis and I'm going to explain you what is that. So rather than giving just usually what I do is I give you a PowerPoint file But rather than giving a PowerPoint file, I'm giving you an explanatory Word file which has all details that's quite required to perform panel regression analysis. Right, and then I would open also the data set. Right, I will open the data set. So it will open, it's a CSV file, as you can see, the extension is CSV, a comma delimited file. Right. So it will open that as well. So if I will to expand these things, what you'll see here is this information. Right. A company is there, the company's name is given, and the years are given, right, for that each company, and the sales value in millions, advertising expenditure in millions, as well as R&D expenditure in millions are given. So you can see then the company B information is given, and that also you can see from 2005 for each company, right? You can see to 2025, 20 years data is given. And same thing for company B from 2005 to 2024. So likewise, information is given, right? So here what we are trying to see is, can we predict sales using advertising expenditure and R&D expenditure? So here the dependent variable is what? Sales, and we have two independent variables, right? So that's what you have to understand regarding this particular information. But however, I'm now going to ask you an important information. You have to very carefully look at it and let me know the answer, right? Check very carefully and let me know. Now, how many observations are there in this data set? In this Excel data set, how many observations are there? So you go down, down, down. You can see 200 observations are there, isn't it? Right? Do you agree? 200 observations. It's 201 because of the variable names on the top row. So there is 200 observations. Do you agree with that? Are there 200 observations?
Yes, sir.
Yes, indeed. Very good. The next question is, but how many companies are there? Are there 200 companies?
No.
No. There are no 200 companies. Actually, you can see if you carefully look at, there's company A. So I have given the number 1 to that. Right? The group. I have given so I have made it number 1 group. Then B number 2. C number 3. Likewise, how many companies are there?
10 companies.
10 companies. 10 companies. Very good. So we call each of this set as a panel. Now this is the first panel. Company A represents the first panel. Right? These are called panels. The groups are known as the panels. Right? Hope you now understood the structure. So actually there are no 200 companies. There are only 10 companies. Right? Each company has how many years of data? 20 years of data. So 10 companies into 20 years, you have 200 observations. Is that clear? Is that clear? Now I'm going to tell you a very important point. You have to understand this now very carefully. Right? If you run the regression analysis that I taught you, Already I told you a regression analysis, which is called what? The OLS regression, ordinary least squares regression analysis. That's the ordinary least squares regression analysis. If you run the OLS regression analysis, ordinary least squares regression analysis, right? What will happen is data will treat each observation here as a separate company. But if you run the normal regression that I have already told you, which is the OLS, ordinary least squares regression analysis, what Stata will do? Stata will treat each observation as a separate company. In that case, how many companies? The normal regression will treat how many companies? We'll take it as how many
200
companies? 200 companies. Very good. 200 companies. Is it correct? Are there 200 companies? No. There are no 200 companies. In fact, there are only 10 companies. So that's why we need to run a special regression called panel regression analysis. Right? If you run the normal regression I taught you, right, here it will do an error. That's a fundamental error. Treating each observation, right, as a company where we have 200 observations here, and it will treat 200 companies. It will take it as 200 companies, which is not correct. Within a company this year, right, observations this year, there are no 200 companies, there are 200 observations. Only we have 10 companies. Is that clear? Is it clear? Right, that distinction you have to understand. Therefore, in that case, we have to run a special regression known as a panel regression. So that's why I'm going to teach you what's a panel regression. So you can see a panel contains the one set of data, so it's companies, and then the year. So year 2005, the sales value, advertising expenditure as well as R&D expenditure is given. 2006, same thing. Likewise, you can see for each company, you have several years of data, right? So that is what you have to understand. Why we require to perform a panel regression analysis. So I have documented that over here. So if you go to the Word file, now you'll see that. So sample data file, see the structure of the sample data file, data session, right? Panel data set, sales data set CSV. Each company has 20 years of data into 10. So you have 200. Now let's go through the steps using the sample data. Now let's see, right? First thing what you need to do is you have to import the data, because the data file is not a Stata data file. So first thing what you need to do is you have to import the data into Stata, right? Once you open Stata, you can import that. Then what we can do is we can start the panel regression. So I have given it as steps, right? Usually you'll have the data in Excel or in some other format, right? Let's say here it's in CSV format, or it can be in Excel format, whatever format is okay, right? But it should be in a format that Stata would be able to, right, import them. So what I'm going to do is I'm going to open Stata. So if you are using Stata with me, so I also encourage you to start doing that with me, right? So I'm going to go over here and I'm going to open Stata, whatever the version that you have, that works. Stata 19. Okay. So you have got Stata 19 opened, first of all. And now let's import that file. So what I'm going to do is easily I'm going to download this file, which I did not do earlier. And then I'm going to import that. So I'm going to expand to show you how to import. So to import that, you will go to File, then Import, because this is in CSV format. And now you can see we should not select Excel. We should select text data, CSV. So this is comma delimited file. So it's a CSV format, right? So you can import it. So choose the second option, right? I went to again file, import, then what? Text data, right? Because this is in a CSV format, right? It is text structured, right? As a text file, but it usually opens in Excel, but it's not an Excel file. So I'm going to click on that. Then it says, okay, so I'm going to minimize this. Okay, then this dialog box appears. So let me expand it again. So then what you need to do is you have to choose the file. You can go over here. So it says from where you have to choose the file. You can choose from here. And you can choose the file. Okay, I'm going to go to my downloads. Okay, the download is there. Data session, whatever panel says data set. So please choose that and press open. And you can see a preview of the file is given. The data structure is given. Yes, you can see the first right row has become the column headings as we expect. And then from the second row, what it indicates is the information. The information is good. Excellent, very good. So there's nothing wrong in that. So what I could do is I could go here and I could press OK. You don't need to do anything, ticking, clicking, anything. You can press OK. Right? Is that clear? Just select the file from this option, open, and just view the preview. And if it looks like this, and then press OK. Right. Okay. So I'm going to do it again. For some reason, it did not come. Right. Yes. Right. Okay. Okay. So it will look like this, and you can see the data has been imported. What's the best practice? What's the best practice? You can see we use the import command. So that's right. It's in delimited format, not in Excel. And it says the location. So that's the command. You don't need to remember that. It automatically gives it. And you can see that there are 200 observations and 6 variables. And best practice is what? You can see it's listed here as well, the 6 variables. Company code, there's the company, there's the name of the company, the group, right? There are 20 observations under each group, right? And you have the other information. And then you can go, and the best practice is to preview. Just open, not preview, just open the data set. What's the command to open the data? To preview, to view the data? What's the command?
Browse.
Browse, very good. And sometimes you don't need to type the entire thing. Even if you say browse, it will open the file, right? Commands can be short. Right? Oh, but you can just want you can browse. Of course, you can see the company name is there, and the first panel is there, and then second panel likewise 20 years of data. Then so the next panel, the 20 years of data is there. There is no issue. So I'm going to close the data edit. Minimize that. And now you have imported the information, right? Is it clear? Is that clear?
Yes, sir.
Very good. So now what we can do is we shall go to the tutorial. Okay, so we did the importation, or you can open the data if it is already in data. And what I would encourage you is you can save the data file. Now it's in the random access memory. So still the data file is not saved. So you can go to File, Save, and save it in a way that you want. So I will call this sales data. Give any name, right? So you can see here, sales data, right? And I'm going to go and save it. So the save command came up, and you can see here under the history, all the commands are listed. We use the import command, browse command, and save command. And you can save these commands as well. I'll show you how to do that later. So you can save that for later use. Right, so you save them. So you're done now. So the data file is now created, right, under my download folder. Sales data DTA. You can create that anywhere you want, right? And that's there. Is that clear now? Okay. So now once you do that, we can go and we can perform. We can start performing the steps for a panel data analysis. So if you enter the data manually into the data editor, you can now, if you just manually enter that, then you don't need to import, right? And that's where, so you use the import command, right? And I'll say whatever, finally save the file. Then you can take down, then save the file as a data set, right? Give any name that you want. So now you have saved that, we gave sales data. Then now we shall come to step number 2. Open the dataset or import the dataset. Do that under step number 1. Then in step number 2, you need to tell data, right? What's the year variable, the period variable, as well as what's the grouping variable, the panel variable. Data doesn't know. Does data know what's the group variable and what's the period variable? Now here, if you look at the dataset, there are 2 variables for that. What are the 2 variables? You can see here, right? The group is the panel. Year is the period variable. Now we have to tell that. Data doesn't know that. We have to tell data what the group variable as well as the year variable. Then only it will understand the panel structure. Then only data will understand the panel structure. So that's what I have tried to do here. If you go to here, declaring the panel data, you can see here the command, you have to do a command saying that xt set. That means set. Right? We say xt set, set the group variable and the year variable. So these are the variables group and year. Group is the panel variable and year is the what? Period variable. So maybe in some other data set, there might be different terminology. You might have given different, right? You might have used different variable names, but first give the panel variable and then give the period variable. So copy this, and put that into this data command over here. So what I did was I copied and I tell, okay, now I'm going to declare that I use the xtset command to say the group is the panel variable and the period variable is there. So in case if you have used some other terms, you can give the term. Maybe for the group, you might have used panel. So in that case, use paneling. For the, let's say, year, instead of year, you might have told period, then say period here. Likewise, we have to give the proper name. So here, xtset, I'll say group and the year and hit enter. Then you can see State has identified now the panel variable is a group in our data set. And it's a strongly balanced because why? Each company has 20 years of data. But sometimes it might not be the case. Some companies might not have 20 years of data, but here it's there. In a real situation, it might be not the case, right? It might not be the case. Please hold on. I'm getting a call that I need to take. Right? Give me a call. Give me a moment. Hello. Oh, just students. Sorry about it. I got a call from the cardiology unit, right? So those calls I have to take. So it's not about me, about it's one of my family members. So okay, now everything is okay, but just for a kind of a testing, Uh, so it was fine. Right, Putha. So let's continue. So we were discussing about setting the panel structure. So very nicely now, state identified, right, the panel variable as well as the time variable. It has, you can see it says, okay, the time variable is from 2005 to 2024. So 20 years of data, and delta means the increment. So you can see each year is incrementing by 1, meaning 2006, then 2007, 2007, 2008, up to 2024. So likewise, you can see the increment has gone from 1 unit. So that's why it says delta 1. But not always you will see strongly balanced, strongly balanced means each company has 20 years of data, but usually in actual situation, it might not be the case. Right? Some companies might have started, little bit later, not in 2005, maybe in 2010. You don't have 20 years of data in that case. That's fine. That's fine because it has some data, but not 20 years. So then it will say it's not balanced. Here it's strongly balanced because of that, because each company, right, there are 10 companies, has 20 years of data. Is that clear? So this is, you set the panel structure. You tell Stata what's the panel variable as well as the time variable, the period variable. Okay, so you pass the first command. That's called xtset. Right? Is it clear? Right. Then what we shall do is then, so it says what's that? So here it's from 2018, here it's from 2005 to 2025, 2024, 20 years of data. The strongly balanced indicates that each company has data for all the time periods, 20 years. If some companies had missing years, it would be unbalanced. So here it's not the case. Then step number 3. Then after that, you can check the data, check the panel structure, better to see whether it's okay or not. So in Stata, you can give this command xtdes. Des stands for describe. So you can just copy this if you want. You can copy this and you can go and pass it in Stata. So I'm going to go over here, command, and I'm going to paste it here, and I'm going to hit enter. So you can see it describes. It says, okay, there are 10 groups, 1 to 10. Here's the increment. It goes from 2005, 6 to 2024. 1 unit, there are 20 periods. 10, that means 10 panels. T, there are 20 years. And it even gives the distribution, minimum and maximum, of course, is 20. Then frequencies are also provided. Right. So this is where you can just view whether what kind of structure that you have. Right. So that's just to see. And also you can generate descriptive statistics. Right. So you can use the summarize command for that. So you can see this command is given summarize, and then you can give the 3 variables. So, and you can just see summary statistics as well. So how to do that? In Stata, you can go to Stata and you can type here summarize. ZD, right? Not SC, summarize, ZD, summarize, and then give the 3 variables. So to get the variables, you can go and double click on a variable. So it will come here, sales and advertising. Go and double click that. So it goes here. And then RD expenditure, that also I have gone and double click it. So it's clear. So you can just copy that and paste over here. So summarize sales, advertising, and RD expenditure. And you can hit enter. So you can see summary statistics are given. Sales, there are 200 observations, the mean value 145 million, minimum maximum values are given. Advertising, just to get an idea. Right, these you are just playing with the data and looking at the data structures. Okay. Right. Then you go back again. So you do, then even you can visualize the data. Under step number 5. Under step number 4, you just had created descriptive statistics, generated descriptive statistics. And in step number 5, you can visualize the data. Here you can copy this and you can use the xtline function and command for that. So copy this and let's paste it in the Stata over here. So I'm going to go and paste it over here. So what it says is going to create line graphs, right, for sales. Now you have advertising and R&D expenditure as well. Later on, you can do that. So based on the group as well as the year variables. So let's see what it will generate. Then you can do that for sales. Of course, it's for sales. Then advertising and R&D expenditure. So you hit enter. So it's now drawing a graph. It's some time over here. Now see this graph, a nice graph, isn't it? So what it has done is for the 10 companies, it has graphed the sales, right? During the 20 years, how the sales for each company, it has moved. And you can see in company 1, there is very high volatility in sales. But other than the others are quite the same. There's no quite volatility, right? You can just view that. And now that's for sales. Now I want it for advertising. So what I do is I go to the history, and if I click on an item which I already passed, so it will come over here again under the command. So for an example, if I hit XT line sales, so that command comes here again under the command. That's a shortcut, or if not, you can just copy and paste it. Now I don't want sales, I'll use advertising. So instead of sales, let's say I'm going to go for advertising. I need the advertising graph. So I'm going to double click on advertising, so it will come over here. Or you can just type it or copy and paste it and hit enter. So you can have the same graph for advertising. So again, you can see a quite similar observation, right? For advertising as well, the company one has a great volatility. So just to understand the data, how it moves, works, etc. And you can do the same thing for the RD expenditure. How to do that? So to get the command you passed, you can just go and click on the command you passed, then it will come to the command line and then change it. Now I don't need advertising. Let's say I need RD expenditure, R&D expenditure. So I'm going to double click there. So it will come over here and I'll hit enter. Okay. Okay, RD expenditure. Yeah, quite similar. The first company has a quite huge volatility, isn't it? So just to get an idea. Okay. So that's, you are going to visualize the data. Is that clear, Buddha? To visualize the data, what you need to do? Good. Okay. So I have given some notes on this. So from 2000, you can just change this from 2005 to 2024. Right. Now, even if you want, you can create box plot diagrams. I'm not going to do that, but you can draw box plot diagrams as well and see how it looks, right? Okay, so that's enough related to visually looking at your data structure, right? Your panel data structures. Then first thing what we can do is, now under step 6, you can see, you can run the, now it's fundamentally wrong, right? But as the first step, you can run the ordinary least squares regression, which we ran. Actually, the command that you run, right, you use is the regress command, although you might not have noticed that. So it's very easy to run a regression analysis that we already ran in earlier lectures. This is what I told you. Regress, then the dependent variable, right, sales, and the two independent variables. That's all what you have to give under the command, right? So we ran this. Shall we run it and see? So that's one of the basic steps that you run, although fundamentally there's an error in that. What's the error? Because under pooled OLS regression analysis, this is the normal regression analysis what we ran already. The problem is it will consider each observation but as a separate company. So there are 200 observations. So if you run this command, those 200 observations will be taken as separate companies. Is it correct? Do we have 200 companies here? No, we don't have 200 companies. We don't have 200 companies. So therefore, that's fundamentally wrong. That's wrong, right? But again, it's as a basic step, a preliminary step, we run that and see what kind of relationships are there. So how to run this regression, normal OLS regression, you already know that. How to run that? You go to this data set. So let me expand. How to run a normal regression, Putha? I forgot now. You go to graphics, no? And run bar chart. Is that what you do? No, that's not what you do. You go to statistics, right? And then go what? Linear models and related, and you go to linear regression. This is how you run an OLS normal regression analysis. Can you remember? Okay, OLS regression analysis. So we are going to go there. And then this dialog box comes, which is very familiar to you. The dependent variable, it's the sales and the two independent variables. You can see advertising and RD expenses. So that's all we select usually, and you will press OK. You can see the command was regress. Can you see? So it's given the output regress. Then sales is the dependent variable and the two independent variables. But see the observations, number of observations. How many observations it has considered? 200 observations. Has it considered the panels, the companies? No, it's not. But however, the R squared is 81.24%. That's good. The explanatory power of the two independent variables is that 81%. And you can see in the coefficient table, you can see advertising is a significant predictor. It has a significant positive impact on, a positive impact, isn't it? A positive impact on sales. And RD expenditure also has a significant positive impact on sales. Why significant? Because the sig values are less than 0.05. Is that clear? Although this is not absolutely correct, what you have to understand is, right, this is just a preliminary step to understand what kind of relationship is there in an OLS context, or least squares, that normal regression analysis. Okay. So we check that. The output will give the coefficients, standard errors, t-test, and the p-values, t-statistics and the p-values, just like a standard OLS regression. However, remember, right, that this model ignores the fact that the observations are not independent within each company. That you have to understand, right? That you have to understand. So you can understand that observations are not independent. The observations are pertaining or belonging to each company, right? The first 20 observations belongs to company A. The next 20 observations belong to company B. So it's not independent. Here it has considered these 200 are independent, come from 200 independent companies, which is not the case. Right? Is that clear? Right. Now let's try to understand how to run a panel regression. Right, running a panel regression, there are two assumptions. One is that we assume fixed effects. That's what we call the fixed effect specification. We can run panel regression under two specifications. One is fixed effects and the other one is called random effects. Fixed effects and random effects. So I have given a note on that. When analyzing panel data over time for different companies, we often want to control for the fact that each company has its own characteristics that don't change over time, like brand reputation or the long-term strategy. So based on this, we have two ways to handle this. One is fixed effects, where we control for company differences. Of course, we need to control for company difference. The companies are different. Think of this as comparing each company with itself over time, right? So likewise, we have the FE model. The FE model removes the effects of anything that doesn't change over time within each company, like management style or even the company culture. Usually, the company culture is fixed. So fixed effects. It focuses only on how changes within a company, right? More advertising or more R&D affect the company's sales. Right? Useful when you believe each company is unique and those differences could be related to your variance. So this is kind of an assumption that you could make, right? Then comes the random effect model. Assuming differences are random. Now, earlier you assume, right, controlling for company differences. You had to control because you think, that, of course, there are differences. But here what you believe is that the differences are random. This model looks like both within and across companies. It assumes the differences between companies like brand, like being small versus large, firm, or random, are not related to your variables, right? So being large or small is not impacting sales. So RE is random effect model, in short, uses more data within and between companies, which can make the estimates more efficient, right? So even if you did not understand anything related to what's fixed effect and random effect, just understand these are two assumptions. These are two specifications that you can run panel regression, right? Right, you can, when you run panel regression, there are two specifications. One is fixed effect and the other one is random effect, right? The thing is now, what to choose? What to choose? And that's the most important one, right? There are two ways that you can run a panel regression analysis. Then what to choose, right? To choose between fixed effects or random effects, you can use a test called Houseman's test. Houseman test. Houseman will tell whether you should finally select a fixed effect model or a random effect model. So simply just remember this. If in the Houseman test, if the significant value, the p-value is less than 0.05, use fixed effects. So keep this in mind. Right. I told you that there are two specifications. One is fixed effects and random effect. How to choose in between fixed effect or random effect? Perform the Houseman test. And if the Houseman test indicates, right, if the p-value under Houseman test is less than 0.05, use the fixed effect model. If not, then use random effect. If it is above 0.05, use the random effect model. So simply, that's what you have to remember, right, in choosing between what? Fixed effects or random effects. Is that clear? Clear the, like, between fixed effects and random effects?
Yes, sir.
Yes, sir. Yes, sir.
Good, very good. So then what we'll have to do is, so I have given more information. So let's see how to run the panel regression under fixed effect specification. It's very simple. Now see, if I expand this, you will see, now instead of the regress command, I am running the panel regression analysis, which is called xtreg. So when it comes to panel, everything was starting with xt. Xtdes, that means describe. Now here we are going to use xtreg. You don't need to remember any of these. I'm not going to ask you to run any of these at the exam, but I'll show you today, right, at the end, how these are going to be tested. I'll show you a paper, but again, right, xtreg. So you can see sales, the dependent variable, and the two independent variable. And I put a comma over here and say FE. Why? Because I am running fixed effect model. Right? I don't know. Finally, I'll tell you how to choose between fixed effect and random effect. So what I'm going to do is I can run a fixed effect model. So I'm going to copy this. I'm going to go to here, my command line, and paste it. We can also do that. So the same thing, xtreg. Now early it was not xtreg, it was regress. Can you see? Now it's xtreg because it's panel regression. Sales, advertising, the dependent variable and two independent variable, and comma FP because I'm going to run a fixed effect model first. Then later on, I will just change RE to run the same thing under random effect model. And then I'll tell you how to choose in between fixed effect and random effect. Right? Okay, hit enter. You now got a panel regression. You can see here, it says very clearly how many observations are there? Yes, 200, but it identifies how many panels. Earlier, the OLS regression analysis just said number of observations, but here it says now it has identified that there are 10 panels, 10 companies. So observations per group. So regarding panels, we can see there are 20. And you can see here the probability of the F test is given. You can see it's less than 0.05. That indicates what? The overall model is valid. And here you can see the R squared value overall is again 80.59%. That's good. Then you can go to the coefficient table down and you can see here also advertising and RD expenditure both are significant positive predictors. Because why? The sig values are less than 0.05. Right? So this is under which specification? Fixed effect specification. Then we can run the same thing. I'm going to paste the same command, right? XTREX sales, advertising, RD expenditure. Now I will run the same thing as what? RE, random groups. Earlier it was FE, right? So I have given the same command here. If you want, you can see that. What's that? Okay, you can see that make it smaller. So this is random group. You can see the only difference is I put RE. Others are the same. And let me go over here. And let me expand this. So I have put RE. Earlier it was FE. Here you can see the earlier command I ran FE. Now I'm running the same command at RE. Random group. Hit enter. And now it gives a new regression. Same thing, 200 observations, number of groups 10. Right? Okay, got that. Then 10. And you can see again the same information. Now it says probability chi-squared, which is basically similar to F test, but here you are using the random effect model. So you can see it's significant. It's significant. Right? It's significant. So the model is significant. And you can see overall model is also, right? The R squared is 80.61%. So it has a good predictive power. Right? It has a good predictive power. Isn't it? That's also fine. And then if you look at here, again, both the advertising and R&D expenditure both are significant positive predictors. Right? You can see that. Right? But the problem is now, what's the problem? What effect to be used? Is it fixed effect or random effect? What effect to be used? Fixed effect or random effect? To choose between, so that's step number 7. You have to use what? Between fixed effect and random effect. First test you have to perform the Houseman test. To run the Houseman test, you have to copy all these things and put that into the stata window, right? Command window, and run all these things together. So what it simply does is it runs the fixed effect model, stores the estimates, right, in something called FE model, a given name. Then you run the random effect model and you store it in the RE model, you just name it. And then you run the Houseman test in between the FE model and the RE model. Don't worry about this. You don't need to remember anything. Just copy this entire block, right? Entire block, and put it over here. So I'm going to leave it. Oh, let me show it. So I'm going to put it over here. So since there are a lot of text there, I'm going to expand the command window and I'm going to paste it. You can see now, you can see all 4 lines are pasted. Right? All 4 should be pasted together. And hit enter. So it ran the fixed effect model, random effect model, and finally it gives the Houseman test. So in the Houseman test, you can see the sig value is given. Right? So the sig value is 0.3131. Is it above 0.05? Is it above 0.05? I told you under the Houseman test, we have to look at the sig value. Is it above 0.05?
Yes, sir.
Indeed it is. Very good. So in that case, what model you have to run? In that case, what model you have to run?
Fixed effect.
Very good, indeed. Fixed effect model. Right. So I have told you, if the p-value is significant, is it fixed effect? So what effect? So random effect, not fixed effect. Why? I gave you the rule. Remember this, right? It's okay, you make a mistake. If the test is significant, use fixed effect. That less than 0.05, use fixed effect. But here is 0.3131. Then you have to use what finally? As to your final regression. The random effect, Puta. Random effect one. Because 0.3131 is well above 0.05. So therefore, right, we have to use the random effect model. So finally, Puta, what we are going to do is we are going to again rerun the random effect model. So because it's the model that we are going to take there. So I'm going to run this. Okay. I'll take the random effect model out of this. Random effect model. You don't need to run Houseman test again. So yes, or you can just copy and paste this line only. So XT sales, advertising, RD expenditure, and RE. So random effect model, why? Because the Houseman test indicated, right, the sig value above 0.05. So you have to use the random effect. Less than 0.05, fix it. Keep that very well in mind. Right? Then hit enter. Now you got what? Now you got that regression. You got this earlier, but just to confirm. So you can see this regression is there. So let me now lower this one. And you can see this. So this is what you are going to report. Right? I'm going to copy this. And you are going to report in your thesis or in your research paper, because finally under the Houseman test, it was random. So I'm going to copy this as a picture probably as a screenshot. And then I'm going to go over here and I'm going to paste it over here. Because finally the random effect model is what mattered. So this is what you are going to report. So this is what you are going to report, fine. So that's, and you will interpret that both advertising and R&D expenditure has a positive and a significant impact, positive and significant impact on sales. That's it. Is that clear? Right? This is how you perform a panel regression analysis and come to a conclusion. Right? So again, if I give you a small summary of what we did, let me summarize what we did. Right? First thing what you do is step number one, either open the dataset or import the data into Stata. That's step number one. So here the data was in a format called CSV. It's comma delimited data. It's text data basically, but can be opened in Excel. Of course, you saw that. So we imported that. Then we saved the dataset afterwards. We saved the dataset in Stata format. And step number two, we told Stata, right, what's the grouping variable, what's the panel variable, as well as what's the time variable, right? Because we have to declare that here the variables for group and the year. In your some other data set, the terms might be different, then give those terms. So it says XT set, right? Panel starts with XT, right? Then the next one, what we do is under step number 3, we describe the panel structure. XT des. Describe the panel structure, and we saw the panel structure. And we even described the descriptive statistics under step number 4 using summary. These are not essential, of course, just to visualize and just to see that. And you can, in step number 5, you can visualize the data. You did XT lines and you drew some line graphs. Not essential, just to look at. And even if you want, you can draw some graphs, box plots. Then comes step number 6, which is important. First, you ran an OLS regression analysis, which is not essential, but just to see, it's fundamentally not correct to run an OLS regression analysis. Why? Because basically the OLS regression analysis assumes that each observation is a separate component, which is not the case, right? Now, then you have to decide. Now, I told you, then you can run the panel regression analysis, but there are two models, two specifications. What are the specifications? Fixed effects and random effect. So I have just given a basic explanation. If you even forget that, there's no problem. Then how to choose between fixed effect and random effect? For that, you have to run a test called Houseman test. You have to run a test called Houseman test. So once you run a Houseman test, it will tell if the sig value is less than 0.05, use fixed effect model. But that you have to keep in mind, right? So we ran, right, a Houseman test, and we understood the value came as what? 0.3131. So we finally selected the random effect model. So we ran the random effect model. So STREG, sales, advertising, and RD expenditure, comma, RE. So that was run, and we selected this final regression. This is what we did under panel regression analysis. Is that clear?
Yes, sir.
Okay, Puta, very good. So it's not difficult. It's very, straightforward, right? How to run a panel regression analysis, right? Now let me also, now that's the end of panel regression, in fact, right? And that's what I wanted to teach you under panel regression. Okay. Clear? Now let me teach you something additional as well. So I think I did not teach you how to save commands in a do file and execute it again. Isn't it? Did I teach you about do file? No, I did not teach you. Isn't it? Do file like something called do file? No.
No, sir.
I think, no, I did not teach. I'm not going to teach you what's a do file. Now, here you can see, right? You have run how many commands? How many commands you have run? Here, the count is there. You can see under history, you have run 18 commands. Once you close data, what happens? Once you close data and reopen next day, those commands are gone. The output is gone and the commands are gone. And you have to rerun that again by clicking again one by one. But I think that's not efficient. In Stata, you can save commands and rerun any amount of times later. Now I'm going to teach you how to save these commands. There are different ways, right? For that, you can use, right, a file called to save these commands and store these commands that you are running in Stata, and you can write your own commands as well. And I have written sometimes, write very, very elegant commands to make my life very efficient. So you don't need to again click like a small child, right? Every time clicking is also appropriate. Clicking menus. So I save my commands for later use. So new data comes, so I just need to run the commands, that's all. So how to save the commands? So please take down a small topic, saving Stata commands. Please take down a small topic, saving Stata commands. Saving Stata commands for later use. Saving Stata commands for later use. Using using a do file. D-O, do file. D-O, do file. Saving data commands for later use using do file. Using a do file. Let's say using a do file. Using a do file. For later use using a do file. Please take down. And let's see how to now create a do file to save all these commands. Right. So what I can do is, so easily there are different methods, but I'll give you the conventional method. So I'm going to increase the size so you can see. So on the top menu, you can see that there is here, you can see here, a paper with a pencil. Can you see it? So that's a do file. So if you click that, it will open a do file editor. It's untitled. What I did, let me show it again. Let me close it. Okay. So what I did, I went over here and I clicked, you can see here, new do file edit. I click that, then it will open a new file. So it's a text file. In fact, that's a do file where you can store the commands. So I'm going to go to file and I'm going to save this particular do file. And maybe I'm going to give a name for that. I'll say my first commands. Give any name, right? My first commands, right? And you can see the extension is do, and you can press save. Okay. Right. You can see my first commands do, you can give any name, right? So that's the do file. So still I did not put anything. What you can do is you can copy and paste this. Right? You can go over here. You can click one, shift down arrow key, and Control C, Control copy, or you can right click and say copy. Right? You can copy all. You can say Control A, so it will copy, and then Control C, or you can just click here and say copy. And you can put that in the do editor. Test. So all your commands now has come. What are these commands? And you can save it again, save the file. So now you can see, right, these data commands. Now you can run it again next day. Right? If you want to keep spaces, you can keep spaces. The first one is import command. Right? Then that's actually the extension. The second one is the extension. So navigator will expand it. So let's see. So if I expand it, you can see the entire thing. Browse command after that, I gave browse, right? And even if you want, you can keep spaces, right? You can keep spaces, save, then XT set, XT days, summarize, XT lines. So these are lines, then normal regression, then parallel regression, FE, RE, and then this, what we ran for houseburn test. And then finally, we ran the final RE specification. And what I can do is I can even put now, I can keep a space on the top, and I can now even give some remarks. Now, in the do editor, it's in fact, this is commands that you are trying. You can put comments for later explanations. So put an asterisk mark, then it will get green color, and you can say, you can put a comment in human language, right? Let's say important a CSV. Right. So you can see if you put a line, if you insert a line with an asterisk, it will be in green color. That means it's a comment. It won't get executed, even if you try. I'll tell you how to execute that. Then you can save it. Right. Okay. Just I'll tell that later as well. Okay. Now you can see I'm going to minimize this one. And you can see now you do file, all the commands are there. Now let's try to see how the magic works, right? Okay. Now next day, now let's say this day you save these commands. Today you save these commands, and now you are trying to end the session. So you're going to close the do file, and you are going to now quit Stata. You're going to quit Stata. So once you quit all these commands, all this output is gone, right? So I quit that. So Stata went, data went. It went away, right? It went away. No longer it's there. Now comes the magic, right? Next day you come. Let's say you come the next day or next week or next year, right? And you open Stata. You open a fresh Stata session. Now you want to run again those commands with new data or even the existing data. Then what you can do? You don't need to again remember and run tick that and this. What you can do is you can open the do editor. How to open the do editor? You go to the do editor over here, the pencil and document sign. So it opens the untitled one, and then go to file, go to open, and go to open. And open, so I'll go to my download folder because that's where I saved my earlier one. So you can see here, my first command do is there, which I saved earlier. I'm going to open it. Say open. So all these commands are there. So I'm going to make it smaller. So now you can see the Stata window is there as well as my commands are there. Now what I have to do is, simply run it. So I have my command window here, and I can just select each line. If I select this import, it's a command, it won't run. So if I want to run the import command to import the CSV data, I just select this one and run it. Execute selection. So you can see in the background it will work. So I'm going to show that. I select the entire line, import command, and I'm going to use this one to execute it. See, immediately it got executed, right? So here, the information is import. Then this is the browse command. So I'm going to execute the browse command. So you can see the data editor window open. Then I'm going to use the save command. That also will be saved, but it will give an error message why already the file is there. Or you can give a new file name, right? So if I give this, it will give an error message. It will give say that a file is already existing. Then I'll tell what you need to do. You need to replace the existing file, right? That's what you need to do. So I'll just run the command and you'll see by your own eyes what will happen. The save command, it will give an error message. Yes, it says already exists, right? So that was the problem. So I'm going to my do command. So what I'm going to do is, in this case, I'm going to say, put a comma here and say replace. So if I say replace and save, right, I'm going to save it and I'm going to run it, then it will replace the existing file and this error message will be gone, right? I'm going to select this and rerun that. Now you can see it was saved. There's no problem. And then XT set group and here, right, I'm going to minimize to show you things. So XT set, it nice is it. Then I can write describe, XT describe. Yes, the description was done. And even I can run the Houseman test, the fixed effect specification, random effect. So then, here these are also there. The graphs. I'm not interested in that much of graphs now. And I'm going to run the regression, normal regression. It's also there, regress and the things. But I'm not interested in that also. I'm interested in running the fixed effect model. So a fixed effect model, I selected that. Fixed effect, right? And I will run that. See, the fixed effect model, ran it without any issue. I'm going to little bit not maximize this. So I can see both windows. That's what I usually do. I keep the both windows open so I can run it and see what's happening. And then this the houseman command. I have to select all together, right? I have to select all these commands together to run the houseman command. And yes, I selected them and I run it. So finally, the houseman command gave me what? You can see the sig value is 0.3131, which is above 0.05. So in that case, right, you have to run what? Random effect model. So that's what you have selected here, random effect model. Right, I'm going to minimize this again. And you can run for your final regression to be reported. You have to run this. Right, so it's given here. Minimize this, make it small and rerun it because the screen is small. Okay, so you get the nice random effect. So likewise, this is the do file editor where you can save any commands and you can keep any vertical remarks as well. Now, these are green color thing. Can you see on the top? I gave you a green color. Now, if you run to execute that, it will just show that it won't give an error message, right, or whatever, because it's a remark. So I'm going to minimize that and I'm going to run this, just to show you. So it will just print it. We just run it. But if I remove this asterisk mark, then it becomes not green color. It becomes a black color. Now, if I try to run it, it will say error. There's no such kind of command. So therefore, in state and do editor, you can put asterisk to make it a comment. And for later use, now after 1 month, if you're going to come and see that, you might forget what's there. So what I usually do is I put okay comments. So I'll say to browse. The data set. Then to save the data set. Right. Then this is step 1. So I'll say step 1. Right. I'll say put a asterisk. Right. I put an asterisk and I'll say what? Where's the asterisk? Okay. I say step 1. Setting the panel. Likewise, you can give, right? Then step 2, describing the data. And you can save it. And that's for your reference. That's for your reference. You can put that becomes green color, the comments. And if you want to run all, you can just select all and run together. Right? It says, okay, no data in the memory will be lost because I need to. So this thing is to say, I'll put on the top, I'll say clear, then comma all, because data is there in the memory. So it says no, clear all. Right, I just put that command over here, clear all, right, and I'm going to save this, right. It's a command that clears all the memory of data. Now, if I run all, Control A, and if I run that, it will run. What does it say? Clear options not allowed. Okay. In that case, it's not allowing options. Clear all, let's say clear. Okay, no worries. So I'm going to select all and run it again. Okay, now everything is running, right? The data editor open, and you can see finally here, these are all the graphs that's opening automatically. Why? The things are executed. Executed. So all the graphs are open. Yes, finally, the random effect model. I don't recommend that, right? Because you have no control on what's popping up. So this thing is to select the commands that you run and then execute. So that's how you would, right? That's how you would run what? A do file, right? You can store your commands and later use that, right? Later use
Excuse
that.
me, sir.
Yes, Buddha.
Excuse me, sir. Small question. So when we open a fresh data session, at that
Yeah,
point, we wouldn't have imported any data file into data session, right?
of course,
It would be
Buddha. That's
completely
right.
new.
Yes, Buddha. There it will be completely new, and the
A do
importing is
file at
also
that
done.
point, even if we haven't imported it, it would work.
Of course, Buddha, because here
Ah,
we are doing the
okay.
importing here.
Right.
So in then we import and Buddha do the other thing. Actually, that's also a command. Importing is also a command. So that's in the do file. So it will import the data and save the data and do the necessary commands. It will run the
Uh,
necessary commands.
okay.
Got the
Okay,
point?
sir. Thank you, sir. Got it.
No
Thank you.
problem. No problem. Oh, now this is I imported. It says import. You can use the use command. Use command means the open command. If the data set is already in stata format, the stata, it's a stata data set, then you can use the use and next day. You don't need to import all the time. So those are all commands for the importing, using, and you can save them in the do file. Good question. Any further questions? Right. Okay, I think after this, what I'll do is we'll take a small break. And after this, I will take a past paper and I will teach you, right? I'll take a past paper and I'll teach you, okay, how things are tested. And you will see there's only one topic remaining that I need to teach you. And with that, we'll finish our syllabus, right? So the only one topic that remains is called structural equation modeling. That's a separate software. With that, your syllabus is completely over. Right. Okay, so we'll take a break now and then let me take a past paper and explain to you, right, what are the nature of the questions and what's my expectations related to answers, right? So what's my expectation? So I'm going to elaborate on that as well. And meanwhile, if you do have any questions, concerns, right after the break, you can ask any questions, concerns related to your individual assignment. Right? We'll discuss that as well if you do have any individual, questions related to your individual assignment. Right. But now let's take a small break. And after that, let's discuss how these are tested. You will see 80% of the paper, right, you can do with the knowledge that you have got up to now. I'll show you how and why. Okay, so shall we take a small break now? So we'll take a small break and we'll meet at 9:20. We'll take a 20-minute break. Now it's 9. We shall meet at 9:20. Okay. Students, can you hear me?
Yes, sir.
Okay, Pratha, thank you. Okay, so now let me take a past paper and discuss that with you, right? I think I did not discuss a past paper with you, no, yet. So let me show you a past paper and show you, right, what we have discussed up to now is already there. You see that. So give me a moment. I will leave it stop share. And meanwhile, any questions related to your individual assignment? Okay. Let me see past paper. Yeah, we'll put a past paper. So you can clarify if you have any issues. No issues, no problem. So this Sunday, I will discuss about smart PLS probably. So we'll try to discuss smart PLS this Sunday. And with that, almost, our main areas are covered. And I heard on 27th, right, on 27th that there's going to be a cricket fiesta, cricket fiesta. Is that correct? I heard, I don't know,
Yes,
maybe
sir.
yes.
Yeah, yeah.
Yes, no, yeah. So therefore, I take part in that as well. So that week we'll not have lectures, it seems. Right now, let me take a past paper and put it. Let me make page 15 past paper. Do you want to discuss past paper? Yes, no? Of course, yes. Past paper. Right, let me see a good one. March. So I'm trying to locate a good past paper. Let me see. Okay, yeah. So yes, because the past paper is a problem sometimes because, but now I have resolved it. Right, okay. So let me share the screen. Now. Oh, Putta, you can see my screen. Can you see my screen?
Yes, sir.
Okay, Putta, thank you. So this is the past paper. So you can go to week number 15. Can you go to week number 15? It says past paper. And here there's past paper. Because those days some past papers were based on SPSS. So I now have a past paper which is on Stata. So can you please download it and open it? So I'm going to open them. Hope you can see my screen. No, it says past paper. Right. So let me discuss this past paper with you, which is like a model paper. And I'll tell what you have to exactly do. Except one question, the question is question number 5. That I'm going to cover this Sunday. Right. Elaborately, I'm going to cover this Sunday. Next Sunday. In fact, this Sunday is the next Sunday. Today is Wednesday. And with that, the main, all the sections that I want to discuss with you is over. And in fact, we have covered the entire 15 weeks also. Right? Yes, we had some issues with me, as well as sometimes it was different other kind of issues like field trips, vacations, sudden cricket fiestas and other things, but everything is now under control. Everything now under control because we managed the time efficiently and we took some extra lectures. And I'm really thankful to my good students for supporting that. Right? And I did not want to cut any corners, reduce anything. Right? Okay. So except question number 5, you'll be able to do all other things, even at this very moment. I'll tell why. So let's go to the beginning. You are able to download it. Open it, no? It's visible and you could download, right? Okay. So this will be the structure. So question number 1 will be compulsory. And then there will be another 4 questions, out of which you have to write 3 questions. So that's the structure. So question number 1 is a compulsory question. And then there will be 4 other questions, out of which you have to write 3 questions. Right? The time allowed is 3 hours. And this is completely paper-based. You don't need to touch a computer to write this paper. But before, right, in your preparatory stage, now, right, when you are studying, you have to, of course, do the analysis and you have to familiarize with the outputs and other things. Right? So the first question will carry 40 marks. You can see question number 1. The total marks is 40 marks. Then I told you there are 4 other questions, 20 each, out of which you have to write 3 questions. So you can see question number 2, 3, then 4, and 5. Right? So 20 each. So this time the structure will be the same. And just the software that we are going to use is Stata. Right? Not SPSS. SPSS was taught to my good students sometimes back. But the problem in SPSS is that you have to install that, you have to crack that. It's morally having some issues to crack software and use cracked software, even for education purposes. So that's why we shifted into a legitimate software. So we study something legitimate with legitimate resources. Right? So I had to take that decision because of that. Because while I preach ethics and I try to do things ethically, then if I'm trying to teach my students to use cracked software like SPSS and others, then that's a problem. So that's why I wrote to Stata and got the Stata package for you. Okay, right. Let's come back to the question paper. So you can see question number 1 is a case study. Right? And you will see it's very similar to the case study we discussed last week. Right? Last week, did we discuss a case study? Yes, we discussed. Even before that, we discussed a case study. Right? On Sunday, we did it as a group work. And then also last Wednesday, we discussed a case study. So you'll see it's quite very similar. You'll see why. Now see. Now here this is about internship satisfaction. Case study assessing internship satisfaction factors. Internship satisfaction plays a pivotal role in shaping the experience and perceptions of interns within organizations. Accordingly, a study was designed to investigate the determinants of internship satisfaction among interns who are undergraduates. The researchers endeavor to understand how mentorship quality, task meaningfulness, and organizational culture influences the overall satisfaction of the internship. Now, by looking at this statement, can you identify the independent and the dependent variables? So likewise, we have to now understand the main issue and the main variables. And of course, you can go and confirm the main variables by looking at what? The questionnaire, because it says the questionnaire provided in detail in Appendix 1. The question comprises two sections. Part A focuses on the demographic information and Part B on the independent and dependent variable, right, that employs a 5-point Likert scale. Data collection involved 250 interns whose responses were compiled to an stated dataset. Better to a stated SPSS, right? Stated dataset. Subsequently, a data analyst conducted specific analysis, and the findings are given in Appendix 2. In Appendix 1, you have the questionnaire. In Appendix 2, you will have now what? Data outputs. Keep that in mind. At the exam, you are given outputs and you have to interpret the results. Okay. Now, first question. State the possible quantitative research objectives based on the given scenario. Right? But before that, better to go and look at the questionnaire. Go and see Appendix 1. Here. In the Appendix 1, you can see the age is requested, your gender of the respondent, of the intern, the study, third year, final year. Then age is also requested, and then you have the dependent and the independent variable. So you can see it starts with mentorship quality, the task meaningfulness, organization culture, and finally internship satisfaction. Now tell me, how many independent variables are there? How many independent variables are there?
3.
3. Very good. Excellent. 3. So very correct. So you have mentorship quality, task meaningfulness, and organization culture as the 3 independent variables. Right. First of all, mentorship quality, then task meaningfulness, right, and organization culture. So let's call it quality, task, meaningfulness, and the culture. And then finally, you have the satisfaction. Right. So what's satisfaction here? What's satisfaction here? The dependent variable. You can see DV. Even some indications are given. But on the other hand, by reading the first paragraph, you could have identified it. Then in Appendix 2, you will see what's being given is the state outputs. Regression output, Cronbach alpha output, factor analysis output are given. Can you see that? Right? You will get a quite similar structure in the paper, right? Right. Let's now go one by one. Okay. State the possible quantitative research objectives based on the given scenario. Can you tell the quantitative research objectives? I told you that we can come up with how many kinds of quantitative objectives? Usually.
4.
What's in the video? I'm very happy. Excellent. Oh, objectives. Why I did those case studies? Yes, as a classwork, it might carry maximum 2 marks, right, per classwork for 2.5 marks. But why I did that was to give you a first-hand hands-on experience, so you could attempt these examination questions and earn 40 marks. Very good. So you are giving answers very nice. So what's the first objective? Quantitative objective. To assess the level of what? Internship satisfaction. Right? To see the dependent variable, the level. And of course, you can see the other independent variables levels as well if you want. Then number 2, to examine whether the internship satisfaction differs based on what? Demographic characteristics like gender, class rank, and years of study. Likewise, you can look at. That's number 2. Number 3, to investigate what? The relationship between the 3 independent variables, right? The 3 independent variables and the dependent variable. What are the 3 independent variables? We have to name them. What are those? Quality, meaningfulness, task meaningfulness, and culture on internship satisfaction. Right? The relationship between. Then the 4th one is what? The 4th objective would be what? What's the 4th objective?
To investigate the impact of the 3 independent variables.
Very good, excellent. To examine or to investigate the impact of the 3 independent variable. Again, what? The quality, meaningfulness, task meaningfulness, and the culture on the internship satisfaction. So likewise, you have to very clearly indicate the 3 or 4 objectives. Now it says possible quantitative objectives, so write all 4. So at least if you write 3, then 2 into 3 is 6. But again, I encourage you to give the max, right? 4 research objectives. Then state appropriate hypothesis for the given scenario. Can you tell one hypothesis? How many hypotheses you could write? How many hypotheses you could write? If you have 3 independent variables, very good, excellent. If you have 3 independent variables, and if you have moderators and mediators, it will increase. But if you have 3 independent variables, you will have 3 hypotheses. What are the 3 hypotheses? H1. H1 is what? The internship quality. The internship quality has an impact, has a significant impact, or has an impact on what? The internship satisfaction. That's H1. H2, task meaningfulness. The task meaningfulness has a positive impact or has an impact on the internship satisfaction. Then H3, what's H3? The culture, the organization culture has an impact on the internship satisfaction. So likewise, you can come up with your hypothesis. And if you are now asked to draw a conceptual diagram, is it possible? Yes. Just write 3 boxes, which, as I told you, explained to you, right on your right hand side, the left hand side, and then draw arrows that connects into the dependent variable, which is internship satisfaction. Right? Okay. Okay. Then comment on the reliability on the of the dependent variable, which is the internship satisfaction. So for that, you have to go and look at the second appendix. Okay, this is second appendix. What do I need to consult to see the reliability of the dependent variable? Is it regression, convex alpha, or factor analysis? Forgot no. What do you need to see? Regression, isn't it?
Convex alpha.
Very good. Not regression. Regression is looking at the impact. You have to look at the convex alpha. You can see dV1, dV2, and dV3. Where is that? You can see dV1, dV2, dV3 are the dependent variable. Again, dV1, internship satisfaction, dV1, dV2, dV3. And you can see here, indeed, it's the convex alpha. And yes, the convex alpha values are given, statistics are given. What's your conclusion? Is the sub-questions of the dependent variable reliable?
Yes.
Yes, indeed, it is. Why? Why is that?
Because the
Why do you say
alpha
it's
is above 0.7.
very good? Excellent. Here, the alpha value is above 0.7. It's in fact 0.79. So that's an extremely good value. So therefore, you could say that, right, these three questions are consistent or reliable. Nice. So that's the answer for that question. Is it a big deal? No. Same way that you answered your case study question. Then D, comment on the consistent value, the construct validity. Comment on the construct value of the dependent variable. There are three questions, and you need to see whether those three questions has construct validity. Or again, the internship satisfaction dependent variable. How can you check that, Putha?
Through factor analysis.
Very good. Excellent. Through factor analysis. So go to appendix 2 again and look at the factor analysis. Yeah. Factor analysis. Right. This is the factor analysis output. By looking at this, what can you say? Regarding the construct validity of the three questions on the dependent variable, what can you say? Is it having construct validity or not? Yes, you can see very well.
Constant validity.
Yeah, it has a construct validity. Why? It has loaded as one factor. Pick a factor. Can you see? Right, it has loaded as one factor, and you can conclude safely there's construct value. Whenever factors then there's a problem. Right, good. Right. Then we shall go to the next question. Using the regression, right, you have three things to do. One, comment on the overall validity. Number two, explanatory power, and recommend strategies to increase internship satisfaction. Right, let's go to the regression. So what's the analysis that you are looking at? Of course, it says to look at the regression analysis. So let's go to the regression analysis. Right, first one is whether the overall model is valid. Is it valid?
Yes, sir.
Yes. Why?
Because the significant value is less than 0.05.
Very good. Excellent. Here, the probability F value is here as very correctly noted, right? 0.000. So it's less than 0.05. So therefore, you can conclude safely what? The overall model is valid. Perfect. Right. Then what's the explanatory power of the three independent variables? What's the explanatory power?
15.3%.
Very nice. It's 15.3%. Perfect. So what it means is the three independent variables explain 15.3% of the variation of the dependent variable. Is it good? Is it good? No. Right. It's not at least 50%. So that means only 15%, right? Approximately 15% is explained only by this. Internship satisfaction is explained by only by these three variables. That means there's almost 85% explained by some other variables other than these three variables. So that so it's not so good. The explanatory power is not so good indeed. Very low. Right, very good. Then can you provide now strategies to increase internship satisfaction? What are the strategies you can explain? Now be extremely careful, right? I increase the size to see you can see better. Give strategies, right? Remember this very well. I'm going to again repeat this, right? Okay, I'm going to repeat this again, which I taught you again and again, right? Always I told you what? Always look at and always give recommendations based on what? Significant predictors, significant variables. Here you can see mentorship quality. Is it significant? Is it significant?
No.
Mentorship quality? No. It's 0.249, which is not. So you cannot give any what recommendation on that. Then task meaningfulness. Is it significant? No. It's also not significant. How about organization culture? Yes, it is significant. So you can see there's a positive impact of organization culture on internship satisfaction. So your recommendation should be only on what? Increase the or enhance organization culture, conducive organization culture. The top leadership should take steps because those are the people responsible for the organization culture to come up with a better culture. And you can explain some strategies to that end. On the other hand, if you told something related to mentorship quality or task meaningfulness, you will reduce marks. We'll have to reduce marks because you are commenting on something that is not significant. So give recommendations only based on significant value. I can see that some one students, maybe his or her mic has a bit got unmuted and we can hear some of your private conversations or maybe. So be careful. Okay. Right. So you can see 40 marks. Did we discuss all? Yes, we discussed this in the class. And in fact, we discussed this right as questions as well. Okay. Then question number 2 is panel data analysis. Did we discuss that in the class? No. Panel data analysis. No. Ending, no? That's the very thing that we discussed today. Isn't it? ඒකනේ අද discuss කරා. So suppose a researcher is interested in exploring the effect of financial development on gross domestic production volatility. Accordingly, data was collected for the following variables by the researcher. So fluctuation of GDP, so SD GDP, standard deviation GDP, dependent variable. So that's the fluctuations, variation. Then you have considered 3 independent variables, financial development, taken by ratio of total deposit to bank to GDP, then trade openness as well as per capita income. Then you have got in Appendix 3, the panel revision results. First question, explain what is, no, don't worry, I did not teach you what's sensorization, so don't worry about that. Just ignore that, right? I'm not going to test anything. At that time, I taught what's sensorization. Now, even now I could teach that, but again, since I did not yet teach that, I will skip this one. So if I have not taught you, my examination philosophy is very clear. If I have not taught something, I'm not going to test that, right? So don't worry about sensorization. Okay. Then, so the question, discuss the model significance based on first panel regression output, i.e. regression with fixed effects. I told you that panel regression could be run both in fixed effects and random effects, right? So whether the fixed effect model is significant. Shall we go there? Okay. So what I'll do is I'll break the screen. Yes, breaking the screen. Right, then that will make our lives easy. View, you'll go to view and you'll break the screen. Split. Right, okay. So I split the screen and I will go to Appendix 3. This Appendix 2 and this Appendix 3. In the Appendix 3, you can see here, let me leave it split. Of course, the splitting is there, but again, let me expand it. Right. So the second question is the model significance under fixed effect model. How to know whether this fixed effect or random effect? Now there's the one regression output here, and then there's another regression output here. And then you can see the Houseman test is there. And Houseman result is also there. Right? You can see it. Now tell me how to identify whether this is a fixed effect model or the random effect model. How can you tell that? Look carefully. In the regression, it says what? XT-reg, the dependent variable and the independent variables, 3 independent variables are there. And then FE. FE shows what? Fixed effects. Then discuss the model significance based on the first panel regression, fixed effects, right? So by looking at this, what can you say? Is the model, the overall model significant?
Yes.
Is the overall model significant? Yes,
Yes.
because why here? Yeah, very good.
Less
Probability
than 0.
says yes, less than 0.05. So indeed, it is significant. Right, then let's go to C. Based on the results of provided in Appendix 3, discuss which specification, fixed effect or random effect is okay. So to see whether you have to use fixed effect or random effect, you have to look at what? Today I told you. What you have to look at? Houseman test results. So go to the Houseman test, which is at the bottom. You can see Houseman test is there. Houseman fixed effect, random effect. And here you have got the probability value what? 0.0, right? 0.0235. So I told you what? If less than 0.05, use what model? Fixed or random? Fixed effect model. Very good. So based on that, you can interpret the result. Therefore, the answer for C is use fixed effect model. So did I teach you this? Yes, today. Then suggest recommendations to increase GDP based on the selected appropriate panel regression. So in that case, you have to go and use what? The fixed effect model. So the fixed effect model is, so if you give recommendation based on the random effect model, you get no marks, right, for that question. Now here it says fixed effect, so you have to use fixed effect. And now go and see, okay. So you can see you have to deal with deposit GDP, right? In fact, there is a negative sign, so you have to look into that. You have to decrease this particular variable to increase the, variation, right? Or to decrease the variation, you have to increase this variable. Likewise, you can interpret, right? But again, you should not give that recommendation. Why? And you say that deposit GDP, right? Can you give any recommendation on that? Deposit GDP. What I told
No.
earlier, is it correct? No, you can't. You cannot say decrease deposit GDP or increase the deposit GDP. You cannot tell anything. Why? Because it's not significant. So if you tell that, you lose marks. Then trade openness. Can you give a recommendation based on that?
No.
You can't. Right? It's not significant. So don't give recommendations on insignificant items. How about the GDP PC? What's that? GDP PC is what? It's the per capita income. Log of GDP PC. So what you need to is you need to increase them, isn't it? So then if you increase that, the ST GDP will go up. Likewise, you can look at that and you can give recommendations. Right. But in fact, what you have to do is now these the GDP variations. So in that case, to reduce that variation, you have to, kind of have the log of GDP PC evened out. So likewise, you can come up with some sensible recommendations. But my point is that give recommendations based on significant results and on the proper specification, whether it's fixed effect or random. Right? Okay, is that clear? Right. So now let's come to question number 3. Right? Question number 3, factor analysis and test of differences. Differentiate between independent sample t-test and paired sample t-test using an appropriate example of your choice. Right? What's the difference between independent sample t-test and paired sample t-test? Did we discuss that in the class? No. Yes, we did. We had a lengthy discussion on this. Independent sample t-test and paired sample t-test. What's the difference? In the independent sample t-test, what you do? You compare two independent groups. In the paired sample t-test, yes, the same individual or the same company, you take two characteristics and compare. What were the examples we took in the class? Independent sample t-test. Trained and untrained group, we compared the mistakes. You can give the same example or some other example of your choice. Paired sample t-test. It was the metric operation. For the metric operation, we took the what? English results as well as mathematics results. The same employee has done English and mathematics, and we wanted to see whether there was a significant difference between that. Right? You can explain the things, even the same examples that we had taken in the class. Okay, is that clear? Yes, indeed, we discussed all these things. Okay. Then explain the purpose of performing a factor analysis. When I taught you factor analysis, I told you there are two reasons why a person would perform a factor analysis. What are the two reasons?
To check the construct validity of a variable.
Very good. Number 1, to check the construct validity of a variable. Number 2, data reduction. Perfect. Right. I'm very happy students are giving answers. Right? Because still you have not 100% revised that because still the course is going on. But you could remember that. I really appreciate that. Right? Then C. Now C is basically you have to look at given scenarios and come up with possible answers. Right? Cases are given. These are small cases, caselets or scenarios, and you are asked to give small answers. Right? You have to give answers based on these small cases. Now look at the first one. A pharmaceutical company is testing a new drug designed to lower cholesterol levels in patients. They have conducted a clinical trial with a sample of 50 participants who have high cholesterol levels. The company wants to analyze whether the average reduction in cholesterol level, right, after taking the drug is statistically significant compared to the population means cholesterol level, a given cholesterol level, the benchmark 239. So usually 239 is the benchmark. So if something is above, then you will say high cholesterol. So you have now taken now this is the benchmark and you want to see whether the 50 participants average cholesterol level is significantly higher than 239 or not. What's the test that you do? If you want to compare the sample mean with a benchmark, what's the test that you do? One sample t-test. Can you remember what was the example we took? The bulb example. In the bulb example, we took 10 bulbs out of 2000 bulbs and the average burning time was how much? 867 hours. And we compared that with the benchmark of how much? 1000 hours. Can you remember? Can you remember? I'm teaching this for right, past 20 years, so I can even remember the examples because I teach that. But you are not teaching that. Therefore, what you need to do is you need to revise that. You need to go through that, learn it. But I can remember all with numbers because I'm teaching this right for last 20 years. So I think the same example I might have taught about 50, 60 times. But you are learning for first time. Therefore, go through the notes. Right, go through the videos if there are. For you, the videos are not available, but on the other hand, now these videos are at least there. Right, go through the notes, get ready. Right, let's go to case number 2. A marketing team is testing the effectiveness of 3 different advertising strategies, ABC, on sales conversion rates for a product. They have implemented a cash strategy in different regions and collected data over 3 months. What's the test Putha you perform? What's the test you should perform? When you want to compare 3 groups, what's the test that you perform? One way.
One way and over.
Very good. One way and over. Indeed. And if you want to see the exact differences, what you perform? If you want to see exact difference, what you perform? Bonferranis or Tukey's. Bonferranis or Tukey's post-hoc analysis. Likewise, you have to be specific. And of course, now you might be studying. And I encourage you to go through the notes because we have covered, you can see, we have covered almost all important analysis. I did not leave any stone unturned. I gave you my full knowledge. Right? We use the time very effectively. And you might now be able to read and understand almost any research paper, right, with this analysis. Right, then case 3. A researcher is investigating whether there is a difference in the pain relief efficacy between 2 types of painkillers and used to treat chronic lower back pain. Right, lower back pain. The study involved 50 participants with chronic lower back pain, randomly assigned to either painkiller A or painkiller B. After a month of treatment, participants were asked to rate their pain relief on a scale from 1 to 10, with 10 indicating complete relief. However, upon analyzing the data, the researchers found that the pain relief ratings were highly skewed, with a substantial number of participants reporting very low or very high ratings. The distribution of rating did not meet the assumptions required for parametric tests. The data is not normal. In this case, what's the test that you have to do? What's the test you have to do? Can you do an independent sample t-test? No, you can't. Why can't you do that? Because
These are
the test of normal.
non-parametric.
Very good. The data is not normal. Right? So you have to go for a non-parametric analysis. Indeed, you have to go for a non-parametric analysis. So what's the non-parametric analysis for an independent sample t-test?
Mann-Whitney test or Wilcoxon rank sample.
Very good. Excellent. Mann-Whitney U test or Mann-Whitney test or Wilcoxon's what? Wilcoxon's? You are correct.
Rank sum.
Rank sum test. Not sign rank test. Wilcoxon's rank sum test. So, Mann-Whitney test, which is the same. In SPSS, it's called Mann-Whitney test. In Stata, you call it the rank sum test, Wilcoxon's rank sum test. Indeed, absolutely correct. So that's the test you have to do because the data is abnormal. Right? Is it clear? So now you can see even today, you can write 3 whole questions. 3 whole questions. Question number 1, question number 2, and question number 3. Now shall we go to question number 4? Refer to the description of case study elaborated in question number 1, which we went through of this paper, and the extracts of the output in Appendix 4. State outputs 2, now you have in Appendix 4 a separate set of outputs. So describe the variables using the appropriate outputs on descriptive statistics. Right. Then the second question is comment on whether the internship satisfaction differs based on the following demographic variables: gender, year of study, major, and then sector. Audit, private entities, public entities, BPO, likewise, there are sectors. And then finally, comment on the relationship of selected variables with internship satisfaction based on the output on correlation analysis. So you have been given a correlation analysis as well. Right, let's start with the first one. Describe the variables using the appropriate output of descriptive statistics. Right, so let's go to Appendix 4. Let me break the screen, then it will be easy. You can see more the question. First, split the screen. So then you can go over here. Okay, here you go. Okay, let's go to the first one. So let me trace this bar. Right, now you have got this one. Here result 1 is what? Result 1 is what? Descriptive statistics. So to describe the sample, you have to look at what? Descriptive statistics. So in this case, the three independent variables and the dependent variable is given. And you have to now describe this. You can see the internship satisfaction is around what? You can start with the dependent variable, 3.5, almost 3.5. Is it good? Not so good, isn't it? In the 1 to 5 Likert scale, it's only 3.5. That's a problem. And likewise, then you can see, but on the other hand, all independent variables are also above 3. These above 3, but not 4. And out of that, you can see these two variables are having the highest. Like in the also, yeah, 9.3. So what is the highest is task meaningfulness. Right. Likewise, then you can comment on the standard deviation, skewness and kurtosis. So all the skewness and kurtosis of these variables are less than 3, plus or minus. In fact, that's a good indication. Likewise, we have to comment on the descriptive statistics for the independent and dependent variables. Then you are asked to comment on the analysis on gender. So you can see internship satisfaction based on gender. It gives a result. What can you say? You can see males internship satisfaction is 3.31, females 3.51. Is it significantly different? Is it significantly different?
No.
Look at the p-value. No, very good. It's above 0.05. So there's no significant difference. So based on gender, there's no significant difference. Year of study. So it's year of studies per year. What does it say? Is it significant different? Third year finally? Significant different or not? Again, no. Because the p-value or the sig value is well above 0.05. It's 0.24. So there's no significant difference. In major, so you count the major, business major and non-business majors are given. Is there a significant difference? So business major 3.39, then non-business major 3.5. So is there a significant difference? No. Because again the p-value is above 0.05. So it's not significantly different as well. In sector, so you can sector-wise differences again, 4 sectors are there. Right. And of course, then we have an analysis of variance. Is it significantly different? No. That's also on an overall basis. By looking at the F value, the probability of the F test is not different. But then Bonferroni is individual analysis is done. And here also we can see when there are right group-wise differences. Again, you can see right the p-values are well above 0.05. Here one is very close, but again it's above 0.05. Actually, these are the p-values. These are the p-values. So p-values can be negative. So these are the p-values. So you can see this given over here. And there's no significant difference, which confirms the overall difference as well. But there's something different though. There's overall there's no difference, as well as if you take group wise, there's no significant difference. Then finally, right here it says comment on the relationship of the selected variables with the internship satisfaction. So you can see the internship satisfaction is the last variable. So if you can go to the last one, you can see everything with the, so with the age, is there a significant relationship? No. Because you can see the sig values about 0.05. And they have said there's no systematic relationship. How about the mentoring quality? Internship satisfaction and mentoring quality. Yes, there's a significant relationship, but weak. It's 0.2. Then task meaningfulness. Again, there's significant relationship because it's less than 0.05, but it's weak.
Okay.
Then how about organizing culture? Some I could hear some students' voice, but be careful, right? And we can hear something, right? The private conversations, so be careful. And then here you can see the third one is organizing culture that also has a significant relationship, but it's weak, right? It's a weak positive correlation. So in fact, the age has no systematic relationship. Don't interpret that there's a negative weak relationship because it's not significant. But other than the three independent variables are having a significant positive impact, but weak on the internship satisfaction. So that's how you have interpret, right? So we discussed four whole questions, and based on what we have discussed up to now, right? So you got 100 marks, 40 marks plus 60, 20, 20, 20, 100 marks, even at the moment. But then I teach you structural equation modeling this Friday, right? What's this moderation effect, mediation effect, and how to draw this diagram, how to run this, and how to interpret the results. I'm going to teach you because this is the next generation of regression analysis. With that, we can safely conclude that your entire syllabus is over. And if you want, we can do some revision questions again. But after that, what is required is not your individual assignment as well as group presentations. Okay. I'll teach you this this structural equation modeling, which is a very important topic when it comes to the next generation of regression analysis. So already I told you parallel regression, OLS regression, but then I'll teach you the most advanced regression analysis, which is the structural equation modeling. I'll take them one by one. I'll teach you. Okay, any questions? So I even discussed the past paper well in advance to your examination. Okay. So those are the things I want to discuss with you today. In fact, I discussed with you panel regression analysis, as well as I discussed almost right 80% of the paper. There are 5 questions, so 80%, even more than 80%, I think. I could even claim 100% because you are required to write 3 questions, then in that case it's 100%. But of course, 20 marks remaining, which I'll discuss this Sunday. Okay, students, so that's what I want to discuss with you. So if you have any questions, you can clarify. If not, we shall call it a day. Hope it's clear. Okay, if you have any questions, you can ask me this Sunday as well. Okay. Okay, so with that, then if you don't have questions, concerns, so thank you very much for your active participation. I was very happy to see some students write diligently and enthusiastically answering the questions. I'm really happy about that. So that's what I really was expecting, and I think my students have come into that kind of position now. So with that, then Puta, we're finished for today. Thank you very much.
Sir,
And good night.
the QR code.
Okay, of course, of course. Here. Yes. Oh,
The QR.
attendance. Attendance, my God. Give me a moment, Puta. Give me a moment. Very good. Thank you very much. Questions day, attendance. Please give a moment. Huh? Let me set up the attendance. Indeed, what a sampurna. I completely forgot. Sorry for that. Thank you very much for reminding me. Attendance there. So I have to set up the attendance. Give me a moment. Third session. So it's today, 16 July. So we started at 1930. 1930. That's 7:30. The lot of thank you very much for the 22:30s. We are going to finish. Okay, that's good. And let me also say, allow students to rotate QR code. Okay. So Puta, let me share the screen now. Now be ready with your fonts. Stay there. Okay, Puta, can you see my screen?
Yes, sir.
I will display the QR code. Right, take your time and record your attendance. Okay, please record your attendance. Thank you, Buddha, for reminding me. I'm completely look forward. Is it getting recorded, Buddha? No problem, no? Seems it's fine. Okay, Buddha. So in that case, I think it's fine. So good luck and good night. Please take care. And we'll meet this sun. Good night.
Good night, sir. Thank you.
Good night, Buddha. Thank you. Good night, brother.
Thank you, sir. Good night.
Thank you, Buddha. Good night. Please take care, Buddha. Good night.